Hi friends, welcome back to my channel Simony. It's me Vaishak. Let's focus today practice questions in motion in one dimension. Concentrate on the first question. Two cars travels in parallel tracks. Car A travels with the same speed all the time and car B travels with varying speed. Their velocity versus time graph is given below. Now, analyze the graph. Which of the following is true at time t equal to 10 seconds? Option A, car B is behind car A. Option B, car B is passing car A. Option C is car B is in front of car A. And option D is car B has zero acceleration. Good. The car which has greater displacement at t equal to 10 is actually further from the other car, right? So, what is the displacement of car A in this time duration 0 to 10 seconds? See, that is just the area under the curve AB, correct? So, that is the area of the rectangle ABCD. So, basically, car A has displacement equal to area of rectangle ABCD, right? Now, what about the car B? Car B displacement will be area of this triangle DBC. So, car B displacement will be equal to area of triangle DBC. Now, which area is bigger? Of course, the area of the rectangle ABCD is bigger. That means car A is farthest than car B, or car B is behind car A. So obviously the answer is A. Car B is behind car A. Good. And car B has zero acceleration. There's an option like this. Why it is not true? Because car B velocity versus time graph is a straight line with a non-zero slope. So slope is there, that means certain acceleration is there. Correct. Now the question number 2. A girl drops a ball from height 10 meter. First part is find the speed at which the ball hit the ground. The second part is find the time required to hit the ground. Good. So let's tackle it. Answer for first part. So for that, let us draw a very simpler diagram. The ball is released from certain height, correct? And it is released from a height 10 meter. So let us draw that 10 meter. So initially the speed is 0 and the question is what is the speed at this point, that is Vf, correct? We only have this height. What is that actually? That corresponds to this height corresponds to displacement. Okay, so be careful about the sign. We have to talk about where the coordinate is. It's your choice actually. You can draw the coordinate in whatever way you want. So let me attach the coordinate like this. Here is the origin and my axis is going upward, preferably y-axis. Okay, and the origin is here. The motion is downward. So final position is definitely 0 because it is hitting the ground. So we can clearly write x f is equal to 0 and xi equal to, what is the initial position? Initial position, of course, it is the height, right? 10 meter. Remember, we are measuring from this point. Good. Right. What is the acceleration? The acceleration is acceleration due to gravity, 9.8 meter per second square. Good. Now we got the acceleration, we got the initial position, we got the final position. Now how we can get Vf? We can use equation of motion 3, which is Vf square is equals to Vi square plus 2a into x of minus xi, which we have derived in the last video, right? So therefore it is equals to 0 square plus 2 into, remember, acceleration magnitude is 9.8. However, the direction is downward. So we have to write negative 9.8. Let me write here also. Negative 9.8 into xf is 0 and xi is 10. Definitely the next step is 2 into 9.8 into 10. The negative negative will cancel out. Negative 1 into negative 1 is basically plus 1, right? So 2 into 9.8 into 10, which is nothing but 196. Therefore, Vf is equals to square root of 196, which is definitely 14 meter per second. However, is it right? See, square root of 196 can be either positive or negative. So which one we had to choose? We had to choose Vf is negative 14 meter per second. Now pause the video and think about it. Why it is negative? The reason is the velocity is downward, correct? So that's why we are choosing negative 14 meter per second downward. Got it? So now the second part is find the time required to hit the ground, correct? So let's do that. We got the Vf, so the answer finding will be easy. So second part, Vf we got, so we can use, so if you know the Vf and if you know the initial speed and if you know the acceleration, then definitely you can use the second equation of motion to find time. Okay? So Vf equal to Vi plus A into delta t is the second equation of motion, and delta t we can find from it, right? So let me just rearrange. Vf minus Vi equal to A delta t. Therefore, delta t equal to Vf minus Vi divided by A. And Vf you already know, negative 14, and Vi is initial speed, which is 0, and the acceleration is negative 9.8, which is equals to 14 divided by 9.8, 1.42 second. So that is the time required for the ball to reach the ground. Okay, good. Right, question number 3. Imagine Usain Bolt takes 5 seconds to cover first 50 meter with the constant acceleration. After that, he moves with the constant speed to cover the remaining 50 meter. The question is, what is the speed at 5 seconds? The second question is, find the total time he has to take to cover 100 meter completely. Okay, right. Here what we know is the time duration and the information regarding the distance coverage, correct? So let's draw a small diagram in which this is 0, 50 and 100 meter. This is a track and this 50 meter is covered in 5 seconds. So t equal to 5 seconds, and remaining distance is covered with unknown time duration. So let's write this time as t1. Good. So actually here we can use first equation of motion to find the acceleration. Equation of motion 1 is x of is equals to xi plus vi into delta t plus half into a delta t square. Now xf is definitely 50 and xi is 0 and vi is also 0 because Usain Bolt start from rest, correct? So 0 plus half into whatever the unknown acceleration into delta t. Delta t is nothing but t1 minus 0 because initial time is 0, right? Starting time is 0. So I can write half into a into t1 square. Now that t1 square is nothing but 5 square, right? So half into a into 5 square. Now I can isolate a. Left side is 50, so a is equals to 2 into 50 divided by 5 square. So 100 divided by 25, which is of course 4 meter per second square. We have to find the speed, right? So speed we can find using the second equation of motion. Vf is equals to Vi plus A into delta t. Now Vf therefore equal to 0 plus acceleration we already got 4 into delta t is t1, which is 5. So the speed at a t equal to 5 seconds is 20 meter per second. Let's go to the second part. Xi equal to 50 to final point x of is equals to 100. Now the initial time is 5 seconds and final time is what we had to find, correct? Let me put the units also. Remember here acceleration is 0 because the remaining 50 meter is covered with the constant speed. Remember acceleration is here is equal to 0 because the remaining 50 meter is covered with the constant speed, right? So let's apply the equation of motion 1. X of is equals to xi plus vi delta t plus half into a delta t square. Now x of is of course 100, xi is 50, and vi, remember here vi is the final velocity in the previous question, which is 20. Okay, and delta t is nothing but tf minus ti, so I can write tf minus ti plus half into a is 0 into delta t square, right? So that ender term will be 0, doesn't matter, correct? So 100 is equals to 50 plus 20 into tf minus ti, which is 5. So 100 is equals to 50 plus 20 into tf minus 5, right? Now let's rearrange. 50 equal to 20 into tf minus 5. Therefore, tf minus 5 is equals to 50 divided by 20, which is 5 divided by 2, and that you can write 2.5. Therefore, tf is equals to 5 plus 2.5, which is 7.5 seconds. So that is the total time in which he finished the 100-meter race. Now let's focus on question number 5. A person walks 173 meter eastward and 100 meter northward. If total journey takes in 1 minute, the ratio of the speed to the magnitude of velocity is what? Okay, so let's draw a small diagram to understand it. First he walks forward, right, 173 meter eastward, then 100 meter northward. We can write distance x is equals to 173 plus 100 because distance is the total length of the path covered, right? And we don't have to consider the direction because distance is a scalar. So the answer is 273 meter. Now, what about displacement? Displacement delta x vector equal to 173 I cap because it is positive x direction plus 100 j cap because 100 meter northward means it is in the positive y direction, correct? So we have to find the magnitude of displacement, and for that let us write delta x is equals to square root of 173 square plus 100 square. This will be equal to 200 meter. Therefore, we can write speed. Speed is nothing but v equal to x divided by time duration. So 273 divided by t. Now we are not substituting time here. I will tell you the reason. Okay. Now velocity v equal to v vector equal to delta x vector divided by delta t, and that will be just 173 I cap plus 100 j cap divided by delta t. Now, if you want to find the magnitude of v, I can write magnitude of v as v dash, which is equals to modulus of v vector, and that will be magnitude of the displacement vector divided by the time duration. Got it? And that time duration, we can write it as t, right? Therefore, we can write 200 divided by t. Now let's find the required ratio v divided by v dash, which is 273 divided by t divided by 200 divided by t. Now this is why I said we don't need to substitute the time value because time value is cancelling out. Good. So we can write this is equal to 273 divided by 200, which will be 163.5. This will be equal to 1.36. This is equal to 136.5 divided by 100 by dividing the numerator and denominator by 2. So that must be equal to 1.365 meter. So the closest answer is option C. Now let's move on to sixth question. The sixth question is acceleration versus time graph for a car is given below. Find the change in velocity for time interval t equal to 0 second to t equal to 3 second. So here is the graph, and you can see in the y-axis there is acceleration and x-axis there is time. If you remember, in the last video I was talking about the area under AT graph. The area under the AT graph for a specific interval give you velocity change. Good. So the interval is from t equal to 0 to t equal to 3 second. Now if you concentrate, the required area will be from 0 to 3, right? So basically, to find the velocity change, you can just find the area under this curve, which is essentially area of the trapezium A, B, C, D. Good. So for that, what we can do is apply the trapezium formula, or we can divide the trapezium into rectangle and triangle. Okay, I will give you the both method. So here the interval is nothing but t equal to 0 to t equal to 3. So the area under the curve is from A to B, and you can see that this area corresponds to ABCDA area, right? And there are two methods we can use to find the area under this curve, basically area of the trapezium. Method one is finding the area of the trapezium directly using the formula A is equals to half into A plus B into height. Now this is a mathematical formula in which A and B are parallel lines and h is the perpendicular distance between the parallel lines, or the shortest distance between parallel lines. Now clearly in the picture, the trapezium parallel lines are AD and BC, and the perpendicular distance between them, basically height, is EB or DC. Okay, so I can write 1 by 2 into A is AD plus B is BC into height is nothing but EB. So half into AD is 5 clearly, and BC is 2 clearly, into EB is 3. So this will be equal to half into 7 into 3, which is 21 divided by 2. That corresponds to change in velocity. So the unit is meter per second. Got it? And method number 2. In this method, of course, we have to find the area of the trapezium. However, for simplicity, we can divide the trapezium into right angle triangle ABE and rectangle EBCD. Good. So let's find the area separately. A1 is the area of triangle ABE, which is nothing but half into base into height. Now, of course, base is EB and height is EA. So the area will be a half into 3 into 3, which is 9 divided by 2 meter per second. Got it? Now, A2 is the area of rectangle EBCD, which is length into breadth. Length of this EBCD rectangle is nothing but DC and breadth is of course ZB. So 3 into. So for finding the total velocity change, you can add these two area. So total area is A equal to A1 plus A2, which is equal to 9 divided by 2 plus 6 to 21 divided by 2. This is the exact answer we got using the method 1, right? So therefore, the velocity change for this time duration is 21 divided by 2. Good. Right. Now let's move on to seventh question. A car is accelerating from rest to a speed 50 meter per second in 4 seconds. If the motion is uniformly accelerated kind, find the acceleration. And the second question is total distance traveled in 4 seconds. So let's answer it. For the first question, we know the final speed and we know the time duration, and of course it is the car is starting from rest. Therefore we can write v initial equal to 0 and v final is given by 50 meter per second and time duration is 4 seconds. Therefore we can use the first equation of motion, v equal to u plus. Therefore we can use equation of motion 1, vf is equals to vi plus a into delta t, and by rearranging I can write a is equal to vf minus vi divided by delta t, that is 50 minus 0 divided by 4, which is 50 divided by 4, 12.5 meter per second square. Good. Great. Now let's answer second part. Here we can use the equation of motion 2, x of minus xi equal to vi into delta t plus half into a delta t square. Great. Now vi is definitely 0 and acceleration we found and time also we know it. So we can find the distance traveled. So x of minus xi, anyway, xi is 0 because initial point we can take it as origin. Good. So xf equal to 0 plus half into 12.5 into 4 square. Right? That means 12.5 times 16 divided by 2. That is equal to 100 meter. Good. That is the answer. Now let's focus on question number 8. A cat jumps vertically upward with the speed 4.43 meter per second. Find the maximum height it can reach by neglecting air resistance, provided acceleration due to gravity is 9.8 meter per second square. Let's answer it. To understand the kinematics better, let's draw a diagram. This is ground and the cat jumps with a certain initial velocity. This is cat. Of course, I'm not drawing the actual cat. Good. So initial speed is 4.43 meter per second, and here is the y-axis, and for the axis the origin is O. So when it reaches the maximum height, of course the speed will be 0, or the velocity will be 0. After that only it will have a negative velocity and it will finally reach the ground, correct? So that position I can call it as x of, which is the required height from the ground, and xi is nothing but 0 because it jumped from the ground, correct? Now remember, in this question there is no time information, correct? So which equation of motion doesn't have time term? Think about it. Equation of motion 3 doesn't have time information. That equation just contain information regarding the velocity and displacement, right? Which I can write here, Vf square equal to Vi square plus 2a into x of minus xi. Remember, here the acceleration is always negative g. Why negative g? Because velocity change is in the downward direction. Okay, acceleration is in the downward direction because gravity is pushing downward only, right? Good. And Vf is 0, so we can substitute here, and Vi square we can substitute later on, and minus 2g, x of is h, and xi is 0. Therefore, we can write 2gh equal to Vi square. So height is definitely Vi square divided by 2g, which I can write 4.43 square divided by 19.6, which will give you around 1 meter. So the cat can jump up to this distance from the ground provided initial speed is 4.43 meter per second. Got it? Right. So that means more the initial speed, more will be the height. Okay. It is not linearly proportional because there is no linear relation. We can find it here. It's actually a parabolic relationship. The double the speed, quadruple the height reached actually. Okay. Great. Okay, folks, that's good for today. You can do more practice sessions attached as a link below. Please do maximum questions, right? So stay tuned. We'll be back with a new video. So bye bye. Have a great day.